Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 3 of the third edition Murach MySQL book. It's about how to retrieve data from a single table. So whereas chapters 1 and 2 were kind of orientation and learn the tools kind of chapter. Chapter 3 is the first real content-oriented chapter. And it's in chapter 3 that we learn about the select statement, which is very important to the capabilities of SQL. And we learn about it in a context that I think is pretty cool. It's how to retrieve data from a single table. And the metaphor that I'd like to use that learning how to do SQL is kind of like learning how to ride a two-wheeled bike. And typically when we teach a person, well, this is probably not true anymore. I know that there are some other methods to teaching somebody to ride a two-wheeled bike now, but back in the old days, when I was teaching people to ride a two-wheeled bike, the first thing that we would teach them is how to ride it in a straight line. We just wanted to teach them to keep their balance. So to use the features of the bike, but not use the steering, right? Really concentrate on the balance at first. And that's what retrieving data from a single table is like. It's hard enough to keep your balance without trying to focus on more than one table at the same time. So that's what we're doing. And then in chapter 4, we learn how to retrieve data from more than one table. And that's like the phase of teaching somebody to ride a bike, where you say, okay, well, now that you can ride in a straight line and not fall, now we're going to teach you how to turn. So now we're going to practice on how to ride a bike while turning. Okay. And that's what we're doing in chapter 4 when we learn about retrieving data from more than one table. Okay. So the objectives I'm going to leave for you to read on your own. So we begin by reviewing the syntax of the select statement, and this first part at the top is it's a simple kind of syntax diagram where we say that the select statement has to have a select list. So we have to say select, and then we have to have one or more column specifications, and that the from, the where, the order by, the limit, and some of the other ones, they're all optional. And how do we know they're optional? Because they're in these square brackets. And that's how these kind of simple syntax diagrams work. Okay? So there are 5 clauses that we're going to learn about here that are part of the select. The select clause, the from clause, the where clause, the order by clause, and the limit clause. And we're going to learn how to use each of those. Okay? So we begin by saying select asterisk from invoices. And what is asterisk? Well, it's a very powerful and simple version of a column specification, and because what we're saying is all columns. So the asterisk is also select all columns from invoices. Okay, and what do we get? we get all the columns, and we get all the rows. Now, I'm not going to try to run all of these um, examples in Workbench. But what I am going to do is I am going to bring up a copy of the Windows Workbench and kind of connect the examples that we go through in the lecture materials to one, the textbook, and two, working on Workbench. So I'm going to put you on pause for just a second while I get that set up. Okay, we're back. And I have up my Windows virtual machine, and my copy of Workbench has been started. So we'll click on the connection and get connected. I don't know, it's actually listening to me, but it's listening to me now. And I'm going to close all these windows because I can. And let's try to find the script from the textbook that we just saw on the lecture slide, okay? So you may remember or not that we have files that I gave you that we downloaded from the textbook, and there is a directory that has all the scripts from the book. So let's go find that. So we're going to go up to the toolbar, click on the second icon to open a script file. Okay, and I put all these data under this PC, under the C drive. So let's open up the C drive. Okay, and it's in a directory here, MySQL 3E data. Okay, and the first directory that we have is book scripts. Okay, and there's a folder for each of the chapters. Okay, so we're on chapter 3. And we're going to open up the first one, which is, I guess, script 02. Okay, and then again, you can highlight it and click open, or as I like to do, you can double click it. And here's a whole bunch of the statements that they run in order to create the examples from the book. Okay, so sometimes you're going to have to hunt around to get the right example number, but here we've got quite a few right here. So this one, the first one, is the one that we just did. So let's highlight that. I wish that were easier to see, but you'll have to fool with the configuration of the tool to get it to show the colors the way you would like. And I'm going to click on the left lightning bolt. And where are we? Oh, so what's the problem? Well, the problem is Joel Murach relies on the feature where we highlight, we set the database that we're working on. And unless you hear otherwise in the text, we're working on the AP database. And right now, you can see from the bolding on EX that is set to EX. And so it says that there is no table EX invoices. Well, you're right about that. Let's go back to AP and double click on that database or schema. Now that's bolded. Now let's highlight this one and run it again. Okay. And here it is. Okay. Now, I'm just going to close first of all, I'm going to look in the console and see that it succeeded. So we have a green check mark icon. We brought back 114 rows. Now, why don't we suppress that console so we can see more of the result set? And we see it. And I just want to point out that what we're seeing here is we're not seeing a slider horizontally, which is to say that payment date that we're seeing is probably the last of the columns. If we couldn't see all the columns, there'd be a slider down the bottom. And we are not seeing all the rows because it said there were 114 of them, and we can see them down here. But if we find this later on the right, we go down, we'll see that there's 114 of them. Okay, so we got just what we wanted. All right. Okay, so that's how you would find the code. You'd find it under the book scripts. You'd probably have to open one and then look for the one that matches the example that we're talking about, or that either you're going to be reading the book or you're going to be listening to the lecture or going through the slides. That's how you would find them. And then you would probably have to set AP as the database that you're using, and highlight one of the queries. That's the first one. Here's the second one here, and then hit the left lightning bolt, and you'll get what we're looking for. Okay, so that's what we have. Okay, let's go back and run the first one again. Okay, and I just want to point out that we have asked for all the columns, and implicitly we've asked for all the rows because we don't have a where clause. Where clauses, we're going to learn, limit the rows. They create a test that the rows that wind up in the result set, they have to pass the test in the where clause. So if you have no where clause, you have no test that they have to pass. That means you're going to get all the rows. So by design, we are getting all the columns and all the rows. Okay? So I just want to shrink this and go back to what we see on the slide. And what we see on the slide is kind of a smaller version of what we just saw. So the theory is it has a slider across the bottom because it wasn't showing all the columns. It has a slider down the right sides because it wasn't showing all the rows. And they have a convention, the author has a convention on these, that he'll show you the number of rows that were returned in the result set. Okay? So by default, one of the things we've learned is that by default, if we don't have a where clause, we will get in the result set all the rows from the table. Here's another one. Select, and then the select clause names 3 columns: invoice number, invoice date, invoice total. So we're expecting 3 columns to come back from invoices. Order by invoice total descending, desk. Okay, so that looks pretty good. All right, and as you can see, we don't have a where clause, so we're going to get 114 rows. We are explicitly calling out the columns that we want. We call out 3, so we get 3: invoice number, invoice date, invoice total. And we've asked for an ordering by invoice total descending. The default is ascending, which is written as ASC. You never have to write the default, so most people don't write ASC if it's ascending. It's just assume that's what you mean. So as you can see, the first one here is 37,966, and then the next is 26,000, and then the third is 23,000. That looks like it's working. Okay, and I'm going to go back and take a look at this uh, copy of um, Workbench, because I just want to show you something here. So this is a second example from the book and from the slides. Let's highlight it. Let's run it. And you can see we've got 3 columns. And if we slide all the way down, turns out we have 114 rows. Okay. Now, is this going to be enough for us? Okay. Well, we're going to have 2 differences between the slide we had in the book and the what we want our code to be if you're in my class. First of all, we have a semicolon at the end of every statement. Okay, so he has that here. He didn't have that in the book. Why does he have it here? Well, he has it because he's got a bunch of statements in the script, and he wanted to appropriately separate them. What I want to teach you is I want to teach you to end every statement with a semicolon, even if there's only one. Okay. And then the other thing that he doesn't have an explicit use AP. And as you saw, we had to go over there and double click on AP, which is not what I want us to have to do. So for us, if we were doing something like that, we would say use AP. Okay, and that is an SQL statement, so it gets a semicolon after it as well. Okay, so that's the only difference between what he shows in the book. Well, those are not the only difference. We have a couple of other things that we do on a regular basis that he doesn't always do. Okay, and I'll tell you in a couple of minutes what I want to. There's one more thing that I'm thinking of that I want us to add. Okay, so I'm not going to save this because I don't want to change the courseware material. So let's shrink this. Let's go back to the slides. Okay, so that's the second example from the lecture. Okay, now here's the third. Select invoice ID, invoice total, and then there's a formula for the third each column or equivalent that we ask for. What we give there is called a column specification. And geez, we have a calculation there. And it turns out that one of the really helpful features of SQL is that we we don't have to simply display the values that are in the columns, but we can get the query to do some calculations for us. Okay, so that's why we have this calculation expressed as the specification for the third column. And then we have another thing, okay? It's pretty clear when you think about it that in the result set that the column label for invoice ID would be invoice ID, and invoice total would get invoice total. But what would you get if you put in a formula or a calculation? Well, what you get as the column label is you get the formula, okay? And that's usually way too wide and too clunky. So here's where we introduce a feature called column alias. Okay, and so this becomes the name that this formula column is known by. And this is what shows up in the label for the column. Okay? And then we say from invoices where invoice ID equals 17. Oh, okay, this is the first time we used the where clause. Okay, so let's look at total credits. So the total credits looks like it's a proper column, okay, because we gave it a column alias. That's nice. And then we have, because the where clause uses the primary key of the table and it's equal to a particular value, we know by definition we're only going to get one row, okay? Because there can only be one row with invoice ID 17, and we get one row. All right, that's good. So this is the first time that we haven't implicitly asked for all the rows. And this is kind of the other extreme, almost the other extreme. We ask for something that you can figure out by reading it is only going to give you a single row. All right. Now let's go a little bit farther. Well, let's not go further. Let's go back. I think I was going to be coming back here quite so often. Let's go back to the scripts that came with the book. And now we're on the third example. Okay. And let's highlight it and give it a run, just so we can see we get the same thing that showed up in the book. Okay, so here's the single row that we were talking about. That's good. All right. Okay. Now, I want to ask you this. What do you think would happen if we didn't have as total credits? Let's get rid of that column alias. Now, if you were listening before, you would know that we are going to get just the formula there. So we run this again. We get this formula, okay? Not too user-friendly. Okay, so let's go back here. Let's do an undo, which on Windows is a Control-Z. So we get that back, so that's fixed. And run that again. Okay, that looks good. Okay, and we would make some other changes if we were handing this in as an assignment. We would put a use in front of it. We might make some other changes, but we're not gonna cover them quite yet. Okay. All right. So let's see what the next example brings. Okay. So this one, it has in the select clause, as we call it, it names 3 columns. Okay, so we know we're going to get 3 columns back, and look, we got 3 columns back from invoices. Where, and we have a more, we have a fancier where clause because we're not looking for just a single value. We're looking for a range of values, and there's this between expression. So invoice date between 2018-06-01 and 2018-06-30. So this is in June of 2018. And so the values have to be in that range. And I just want to point out that the way that the between clause works, it's inclusive. So a date of 2018-06-01 would pass the test. A date of 2018-06-30 would pass the test, and all the days in between would pass as well. And we say order by invoice date, which makes sense. Okay. And as we can see here, I brought back 37 rows. Okay. Well short of the 114 that are in the table, but certainly greater than the one row that passed the where clause the last time. and we have an order by, I'm going to go ahead and say here that I'm going to want you guys to always have an order by. Now, when you look at the examples from the book, he doesn't always have an order by, but in the standard SQL, okay, the standard says what happens if you don't use an order by. The order that you get is implementation dependent. So it just so happens that the implementation that we're using, MySQL, brings them back in a reliable order. And generally, I think it brings them back in the order of their primary key. Okay? Now, that's not true for all implementations of SQL. In particular, a very popular one that I've used a lot is called PostgreSQL. And it does not bring the rows back in a reliable order if you don't have an order by clause. Okay? If you write a query without an order by clause and you run it once, you get the rows in a particular order, and then you click and you run it again, you'll get a different order, and then you click and you run it again, you'll get yet another order, and that turns out to be for users very crazy making. So one of the things I said previously was we're always going to add use in the beginning. In the case of the examples here, they're for the AP database, so we're going to say use AP. And in the general case, we're always going to say order by. Now here, we're putting the order by on because they've asked for it. Now, why didn't I bring the order by up in the example before? Let me back up and say why. Well, you don't have to worry about the order of a query that you know by definition is only going to return one row. Okay? So the order by on a query that returns a single row is not really important because there's only one row, there is no order. Okay? Or you could say there's only one possible order. That's probably the way to say it. Okay? Okay, so we don't have an example yet where you have to dream up an order by and add it on, but that's what we're going to be doing. Okay, let's go look at the next one. Okay, now here's one. If you look at the result set, see how you're not returning any rows at all. Okay, now how did that happen? Well, we selected 3 columns from invoices where invoice total is greater than 50,000. Turns out that we don't have any. Okay, so this is, I guess, the opposite of returning all of them. You come up with a condition for the where clause that is so restrictive that you don't get any rows. Okay, and since we don't return any rows, we don't have to worry about the order by. Okay, so I'm just going to bring back the workbench, and instead of working with an example, okay, from the book, I'm just going to create a new script, okay, and let's say that we want to select, okay, we want to select invoice ID. Now, what other fields do we have on invoices? Well, if you go over here to invoices and you click on the a triangle to open it up, and then go down to columns and click on that. You'll get a list of columns. So invoice ID, vendor ID, invoice due date. Now, look what happens. We can actually, when we begin to type in this workbench, sometimes it'll give us some auto completion opportunities. Did it give us invoice due date? No, it didn't. It's giving us table names. So let's say invoice underscore invoice line items. So let's say invoice due. It's not giving us an auto completion. So we want all those. Remember, at the end of the list, we do not put a comma. That's the end of that clause. And we're going to say from invoices. Okay. All right. So we've got that. Let's see what we can do. Let's do that balance due thing. Okay. So in addition to all these things, we're going to have invoice total. There's invoice total. See, that's a column. Invoice total minus payment total as balance due. Okay, so we have that from invoices. Okay, now let's try to run that. Let's give that a run. Well, that's good. So we've got vendor ID, invoice due date, balance due. Okay, they all seem to be 0. Okay, I guess those are all paid. Okay, some of them are paid already. Some of them have not been paid. Okay, what if we just wanted to see the paid ones? Okay, well, we could use the where clause. Okay, here's where I'm going to show you something that's kind of disappointing. Okay, well, I'm sorry. Before we do that, I'll show you something that is not disappointing. We don't have an order by yet, and I've said I would always like, unless we're bringing back a single line, and there's one other special case, I always like to add an order by. Oh, and I always like to add a use. So let's begin with the use AP. Gonna want you to have a use AP up here. Okay, and that with the semicolon. Oh, we have to add this other one. Have to add the semicolon at the end of this. But let's have an order by. Okay, so let's say order by. And what are we going to say? So for right now, let's say order by. It looks like it's invoice ID. Okay. And I think I mentioned in MySQL, if you don't have an explicit order by, you do get a reliable, repeatable sequence. And I think it's the primary key order. Okay. Now, I'd like to teach you to not rely on that because you might be going to some implementation that doesn't do that. Okay, I don't want to only teach you the code that works for MySQL, right? So let's say order by invoice due date. Due date. Okay. Semicolon. All right. Let's click on the left lightning bolt and run that. Okay, that looks good. All right. Let's do something else. Let's let's get the ones that are only paid. Okay. Oh, I'm sorry. I didn't get to that yet. So what if um, instead of ordering it by the invoice due date, okay, what if we wanted to have them in order of how much we owe, the balance due? Okay, so let's see. What's the formula for the balance due? It's invoice total minus payment total. Okay, good. Okay, so we're going to order by that. All right, order by, oh, I didn't want it to say select. Here, let's get rid of that. Order by, it doesn't want to do what I want. So let's type it in. Enough for cutting and pasting. So, oh, I know what I did wrong. As I move between the Mac OS version and the Windows version, I forget to use the right keys. So I just used a Control C there to copy and then a Control V to paste. Okay, now I don't say as balance due here. That's not how I do it. I just I can order it by formula. Okay, and let's do it descending. Okay, so we want the ones that we owe the month, we owe the most on the top. Okay, and put a semicolon at the end. Okay, now I'm getting sick of this not being beautified yet, so let's go up and beautify it. Okay, and now we get the keywords in all caps, and we get the white space inserted. That all looks good. I'm going to want you to do that. Okay. All right, and now let's give it a run. Okay, great. So it is in the order of balance due, descending. So uh, the invoice that we owe the most for is at the top. Okay, that's good. And then we have all the ones we owe 0 for down the bottom. All right. Okay. Now, do we have to put this formula in again? Yeah, it turns out that we do. No, I'm sorry. We don't. Oh, forgive me. Okay. Can we use this name? Can we use this column alias balance due instead of having to put the formula in again? Yeah, it turns out that we can. It turns out that we can use a column alias name for more than just putting um, the title up, the label up at the beginning of the column. So let's go here. Let's not repeat the formula. Okay. And we're just going to put balance due. And we're going to hope that it gets recognized as I claim it will. So let's run that query. And it does work. Okay. So that is really encouraging. All right. So it doesn't work for everything though. Okay. So for instance, it doesn't work in the where clause. So you would like to be able to say here, you would like to be able to say where balance due greater than 0. Wouldn't you? Okay, so we wouldn't have all those lines with 0. And it's going to turn out that this doesn't work. And it's going to be very disappointing. So we run the query, and we get the regex error code 1054 unknown column balance due in where clause. Well, why can we use it in the order by and not in the where? Oh, let's give it a beautify first. Okay. Well, it turns out that there is a what would you call it? A workflow, okay, There's a natural order in which the parts of the select statement are implemented. And it turns out that the ordering is the very last thing, okay? So we're allowed to use a column alias in the order by clause because that is already resolved by the time we get to the last operation that gets done. It hasn't been resolved when we are implementing the where clause, which is one of the very first things that happens within the workflow of executing a select statement. Well, how do we cure that? Well, you go up and you take your formula and you highlight it. And on Windows, you would do a Control C. On the Mac, you would do a Command C. And you come down to balance due and you replace it by its formula. On Windows, I do a Control V. On the Mac, I would do a Command V. Okay, and then let's go down and let's execute this. And it works just fine. So we're getting the column with the column alias in the title, and we're getting it sorted. We're able to use a column alias name, but in the where clause, we can't use the column alias name. We have to repeat the formula, and as you can see, we're not getting rows where it's equal to 0. And you can see we only return 13 of the 114 rows. Okay, so just to remind you, let's close the console here so you can see our whole select. We are always going to add a use, an explicit use. Okay, we are always going to beautify. Okay, now we're going to learn later when we get to statements other than select. Sometimes they don't work. The beautify doesn't work as well on them, but certainly for the selects. Okay, we are going to use column aliases whenever we have a formula. Okay. We're always going to have an order by if we're expecting to return more than one row, because we want to be writing code that would work in products like Postgres. Okay. When we do the order by, we're going to feel free to use the column alias. That's going to work fine. Okay, but when we want to use the same calculation value in a where clause, we're going to need to repeat the formula. Okay, very disappointing, but just the way of the world for SQL. SQL has been around. Commercial versions of SQL have been implemented for 40 years. So the expectations 40 years ago, I think were lower, than they would be today. Today, we probably would find a way to have that work, okay? But in the original version, it didn't work, and people have been dealing with that for 40 years, and you are just going to be another one of those people, just like me. All right. So let's minimize this, get back to the slides. Okay. So we've already seen that there are a number of ways to code the column specification in the select clause. Okay. You can ask for all the columns in a base table. You can ask for a particular column name. you can provide a calculation. And as we're going to see soon, you can use a function expression. And as we're eventually going to see, we can also use a function expression as part of a calculation. Okay? And we haven't used keywords before the column specifications, but there are two keywords that we could use, all or distinct. Okay? And the thing to remember about these two is that all will give you all the rows that qualify, and distinct will keep duplicates from happening. Okay, and what do we mean by duplicates? We mean where the values in all the columns are the same. Okay? Alrighty. Let's go. So, again, as a column specification, you can use an asterisk. You'll get all the columns from that table. Or you can use the names. We've used that. We're pretty comfortable with that already. We can have an arithmetic expression, and we can, and usually do because it's good practice. I'm going to expect you to have a column alias when you have a an arithmetic expression, because it's more useful to know what you consider that to be rather than how to calculate it. And the first function we're going to learn about, we're going to have a whole chapter on functions, okay? But the first function we're going to learn about is concat. And concat, it takes either the value of string columns or literal strings that we put in here, and it glues them together, okay? And when you glue strings together, we call that concatenation, which is why the function is called concat. Okay, so here we're taking the first name column and a space, and the last name column, and we are giving it a column alias of full name. Okay, here's a select statement that renames the columns in the result set. Okay, so let's say you wanted to give your result set directly to the user, okay, and they didn't know the column names. Maybe you didn't want them to know the column names. You can replace the column names with a column alias, so you get a prettier label up at the top of the column. We're not going to do that certainly much in our work in this course, but you should know that that can be done. So here we've got a pretty rendering of invoice number, a pretty rendering of date, a pretty rendering of total, rather than their column names. Okay, and you can do that with column alias as well. Now, if you want to use a column alias, again, for instance, in the order by, it's probably easier to do if you're using things that don't include an internal space. I think you can find a way to do it by putting it into quotes again and all that kind of stuff, but I've had my problems. All right. Okay, here's a select statement that doesn't name a calculated column. As we saw before, when I did that on Workbench, we just get the formula up here. And usually the formulas are too long for the column. And again, we want to be user-oriented. And we don't want to tell people how to calculate it. We want to tell them what that represents, which in our case, in this particular application, would be the balance due. Okay? But again, if you leave off the column alias, this is what you're going to see. Now, in an arithmetic expression, we can do uh, addition and subtraction with the plus and the minus, not too surprising. We can do multiplication and division. Multiplication is an asterisk. Normal division is a slash. What are these other two? Well, div, capital D-I-V, is integer division, and either a percentage symbol or a capital MOD is remainder. Okay, so um, you remember if you're doing integer arithmetic, the best way to express it is not in well, when we do integer math, we get remainders instead of decimal fractions. Okay, so if we say div, so we say three div 2, we're going to get 1. Okay, so 2 goes into 3 one time with a remainder of 1. If we say 3 mod 2 or 3% 2, we're going to get 1 because that's the remainder of 1. And interestingly, we have this order of precedence thing. So the multiplication, the division, the div, and the mod or the percent, they're all equally strong. They all have a precedence of 1. And addition and subtraction are weaker. They have a precedence of 2. Now keep that in mind, and we'll explain what this order of precedence is in a slide or two. Here's a select statement that calculates the balance due. Pretty straightforward. I think we've seen that before. Now, a good practice is to control the sequence of operations by putting parentheses around arithmetic expressions. Okay. Now, here we have a select where we've got two expressions that use the same terms, but they're grouped in different ways. So we say invoice ID plus 7 times 3 as multiply first. And then we have the quantity invoice ID plus 7, that multiplied by 3 as add first. We typically would do, well, we typically would not be either adding or multiplying the invoice ID. So this is all kind of just for our own education and entertainment. But the second one, because it explicitly uses parentheses, we are going to get the addition done before the multiplication. Whereas if we don't use parentheses, in order to tell it the order of operations that we want, it's going to go on this order of precedence. And if we go back to that slide, you'll see that multiplication, division, div, and mod are stronger than addition and subtraction. So that means they have a higher precedence. They get done first. Okay, so if we come back here, it means that this multiplication is stronger than this addition. So it has a higher precedence. So it's going to do the multiplication first and get 21, and then it's going to add the invoice ID, in which case it's going to get 122. Whereas here, where we explicitly use the parentheses, we're going to get a 21, we're going to get the invoice ID, which is 1 plus 7, which is 8 times 3, which is 24, which is why on row 1 we get 22 and we get 24. Okay? Now, it's good to remember the precedence in the order of operations, because if you inherit code from somebody else and they leave an uh, ambiguous expression like this, then you need to be able to understand what's going to happen. But for instance, if you work on my team or you're in my class, I don't want you to rely on the order of operations, the order of a precedence. I want you always to explicitly include the parentheses so that we know what order the calculations are going to be done in. Okay? Okay, so here's the div and the modulo operators. So we have here invoice ID divided by 3 as decimal quotient. So what do we get? We have 1 divided by 3. Yeah, we get 0.333. The next one, invoice ID div 3 as integer quotient. Uh, uh, 3 goes into 1 0 times. Okay, invoice ID modulo 3 as remainder. Uh, 3 goes into 1 0 times, remainder 1. And as you go through these invoice IDs, you're going to get the right thing. What determines the sequence of operations? Well, in the absence of explicit parentheses, it's the order of precedence. If you're if you're a if you're a person who wants to leave behind easily read code, then you put in all the parentheses that you need to determine the order in which these things are going to happen without knowing the order of operations. Okay. Okay, the concat function. Uh, Functions in SQL work like functions in other uh, procedural programming language, things like Python or Java or JavaScript. Okay, we have a function name, in this case, concat. We have a list of either column names or um, expressions. Okay, so we could have an arithmetic expression uh, here, or we could have a function expression. So you can have functions within functions. Okay, so what happens is it's like a mathematical function. So you have a function of these arguments or parameters, and it's a deterministic kind of a machine that turns out a single result. Okay, so concat is expecting strings as the arguments, string values, and it's expecting to return a single string as its result or final value. So we say concat vendor city, vendor state. So vendor city is Madison and vendor state is with. If we concat them, we get Madison with. Now maybe we would want something in the middle, which would be a string that would be like comma space. So we say Madison comma space with, which would be what we wanted. Okay. Now, how many of these parameters or arguments does the function take? Well, it depends on the function. You can look them up either in our textbook or in the documentation. It turns out that concat is a really fancy one. It can take any number of columns, expressions, or function expressions, and if you give it 2, it'll it'll glue them together. If you give it 22, it'll glue all those together. And now it looks like we're doing this in a better way. So we have the vendor name, and then we are concatenating vendor city, a comma space, vendor state, a space, vendor zip code as address. And here it is. And this turns out to be a really important feature for us because as we're going to learn, the style of designing relational databases and querying them, the style it works is that we disaggregate the fields as much as possible. So rather than having a vendor address column that had the city, the state, and the zip code all in one column, we disaggregate them because it is easier to aggregate them within the query with a concat than it is to try to pick them apart if they're in a pre-aggregated column. So this is the query style that really predominates in good SQL practice. Now, you'll notice that for some of the strings, we've been using apostrophes, single quotes as I call them. For some of the strings that we've had, like column aliases, we used double quotes. Now, is it important for us to use them exactly that way? Well, it turns out that on the version of MySQL, as we have configured it for our class, we've said that apostrophes and quote marks are interchangeable. Okay. We could change that. Okay. There are implementations where there is a difference. So you probably do better to have generally to use apostrophes and to use double quotes for things like column aliases. We're not going to worry about that. But if you're using apostrophes, how do you get a proper apostrophe in? Well, we put two sequential apostrophes in, and that means I want one proper apostrophe. I'm not trying to enclose a string. Okay, that's how that works. So terms to know. A function, we've only seen one so far, concat. Okay. Functions take we alternately call them in this language parameters or arguments. They're the names of columns, or they're some kind of expression, or they can even be the name of another function. So we could have another function expression. They're separated by commas, and how many they will take depends on the function, and you can find out by reading the documentation or by Googling them and finding some kind of a helper article. And concatenate means to kind of glue strings together. When we glue things together like that with the text, we say we concatenate them. So the concat function is what we use for concatenation. Okay, now we have some other functions here. We have a whole chapter on functions, but before we get there, we're going to show you at least one other function. What if we wanted to just take the leftmost character from a column value? Okay. Well, we can do this. So we use the function left. Okay. And then whatever string that we want to use. So we can use a column name here, and then the number of characters we want to take. So what are we doing down here? Well, we want to concatenate left the character of first name, and then we say comma left again the first character of the last name. Then we give a column alias initials. So here we have Francisco Alberto, and the initials have become FA. Pretty cool. Now this really illustrates a lot of things. Among them, that you can use functions within functions. So if a function like concat can take 2 arguments, one of those arguments could be a function expression in its own right. And it's very powerful. This is something that we do in other programming languages as well, things like, Python, Java, JavaScript, C++. So people who have done those are probably pretty comfortable with the idea. Here we practice this enough so that even if you haven't had those, had that kind of programming experience, you should get the hang of it. Date format, okay? One of the good things about having a date column, we have 2 types in SQL. We have a date type of column, and we have a date time type of column, and we can pull the values out and format them in a useful way. So how do we pull the values out of a date column? Well, with the date format function. So we give the date. Okay, in this case, invoice date has the type date, and then we give a formatting string. So we want the %m / the %d / the %y. And those are standing for month, day, and year. And how do you know what these are? Well, you look them up. Okay, I never seem to be able to memorize them. I look them up in the text, or I look them up in the MySQL documentation. Okay, and generally speaking, you won't be too surprised by this. You and your user group are using one kind of format or other for dates. And once you get it right, you just take this little picture string here, this little formatting string, and you keep copying it. Okay, so could you memorize them all? Yeah, you could. Do I? No, I don't. I seem to get away with it just fine. The round function, okay? So there are times when the value that's either in a column or is the result of an arithmetic expression has more decimal places than we want to display. And so what we do is we use the function round, and we give it, we have the number, and what's the number? Well, that could just be a column name, or it could be an arithmetic expression. And then we have a column, and and then we have a comma, and optionally we can have the number of decimal places. Well, if we don't tell what the number of decimal places, how should we round it? Well, it turns out we should round it to 0 decimal places. That is such a common use case that we don't make you put the 0 there. Could you put a 0 there? Could you have round number comma 0? Sure, you could. But do you have to? No, you could just say round number. It'd be the same as round number comma 0. So here you can see that we're selecting invoice date, invoice total, round of invoice total. That's just going to get rid of all the decimals. We call that nearest dollar. And then we say round invoice total comma 1, which gives us the nearest dime. So invoice total, you can see here, to the nearest a dollar, it rounds to the whole dollars. To the nearest dime, it rounds to the nearest first decimal place. Okay, and when do we want to use round? Okay, typically in our databases, we define the columns, especially the money columns, to have two decimal places. They're dollars and cents. So it turns out if we're adding and subtracting them, well, we should wind up with just plain old proper dollars and cents. So when would we have to use round? Typically when we have a formula that uses either multiplication or division. If we multiply by a fractional amount, if we multiply by 0.5, okay, or we divide by a whole number other than one, we can get fractional sense, in which case you'll see a lot of times that we're rounding to two decimal places. And again, do you need to do that when you're just doing addition and subtraction on money amounts? And the answer is no, you don't, because when you add and subtract money amounts that only have two decimal places, well, the answer can only have two decimal places. Now, here comes a feature that we're going to do in the homework. That's kind of a practice proof of concept kind of feature. Would you do this in your day job? No, I don't think you would. You would do it to try to test out a formula, but would you actually run a query like this and show the results to users? No, you wouldn't. Okay. So you can put an expression out here without using any columns at all. Okay. Now, when you do that, you don't even have to tell the database that you're using because it's not using any database. It doesn't need a database to interpret an expression that doesn't use any columns from a database. So this says select, and now here's a formula, 1,000 times 1 plus 0.1 as 10% more than 1,000. Okay, and that turns out to be 1,100. Okay, and why does it have a decimal place? It has a decimal place because of the way we did the multiplication. We have 1,000 times 1.1 is always going to give you one decimal place. Okay. Now, here is another case where we're not using any columns. Okay. We're using just these literal values. Well, Ed is first name, Williams as last names. Concat left of Ed 1, left of Williams 1, and then of course we get EW. Okay, is it again, would something like this be useful for some kind of a query that you wanted to show the results to your user community? Probably not. But if you want to test out features and see what the results will look like, well, yes. And we've got a couple of these in the homework assignment. So a select statement that tests the date format function. Okay, so here we're using the current date. Now, current date is one of the expressions that you can use that gets the date of right now. Okay, so we display the current date and then we format the date in two different ways. Okay, again, is the date coming from a column? No. So we don't have to tell it either the name of the column or the name of the database because we're just kind of fooling around to get a feel for the features. And here's a case where a select statement that tests the round function. This is not one that tests the round function. Every time we come out the slides, there's there's some there's some. This is a new version of the slides. This is just a wrong slide. Sorry. Select statement that returns all rows. Okay. Why does it return all rows? It returns all rows because it doesn't have a where clause. If you don't have a where clause, you always get all the rows. It happens to be in the vendors table, we have 122 rows. Not surprising that we got all of them. Here's a select that eliminates duplicate rows. So we add the distinct keyword, okay, and then we have vendor city, vendor state, okay, and we only get 53. Okay. Now, so let's go back. Okay, we're showing the vendor city and the vendor state. We're not saying distinct. So that's another way you can get less. Another way that you can get less than a row in the result set for every row in the table is distinct. It eliminates the duplicates. So I talked about the where clause earlier, but distinct is the other way we do it. And we can see that these are identical rows in the result set because they have Anaheim, California as the vendor city and the vendor state. And you can look in the next one and see they've been collapsed into just a single row, which is why we start out with 122 and we wind up with 53. Now, I just want to point out that distinct is only useful when we are not including the primary key in the list of columns. Why is that? Well, the primary key value is always unique. Okay, so if we had said vendor ID, vendor city, vendor state, the ID would make each of the rows unique, even if the vendor city and the vendor state were the same. Okay, so if we had done that, if we had put vendor ID in here, even though we use the distinct keyword, and we did have repetitions of some values, the vendor city and the vendor state, all of the columns are taken into consideration before we, when we go to figure, do we have duplicates that we should eliminate by distinct? So it takes a little bit of thinking, but you don't want to use distinct when you're including the primary key because it doesn't do anything. Okay, it's only when you have a list of columns that does not include the primary key that distinct can collapse the results. Okay, because in order to collapse two rows, all columns have to match. Okay. When we use the where clause, we typically use a comparison operator. We use equal, less than, greater than, less than or equal to, greater than or equal to, and then two expressions for not equal. Okay, so less than, greater than is not equal, and this exclamation point equal is not equal itself. The exclamation point is the not symbol. Okay. So let's see, this is pretty expressive. So to code the vendors located in Iowa, where vendor state equals IA. Invoices with a balance due, that would be greater than 0. Okay, so two ways to express that. We could say invoice total minus payment total minus credit total greater than 0. or we could say invoice total greater than payment total plus credit total. Before, when we do this, we were not considering the credit total. Vendors with the names from A to L that begin with A to L, well, we could say vendor name less than M. So all of the L's would be less than M. Invoices before a specified date. Oh, on or before a specified date. So less than or equal to that date string. Invoices on or after a specified date, greater than or equal to that date string. Invoices with the credits that don't equal 0. Okay, so credit total, two ways to say not equal, and we see them both. Okay. We can use logical operators, okay, within the where clause. It's very expressive, okay? So we can say, we can take where expressions and we can AND them. So we can say where vendor state equal New Jersey and vendor city equal Springfield. Okay, so that's going to get us just Springfield, New Jersey. Or we can use the operator where vendor state equal New Jersey or vendor city equals Pittsburgh. So that would get us any vendor in New Jersey and any vendor in a Pittsburgh, no matter which of the states it was in. Or we can use the not operator where vendor state, we can say we're not vendor state equal California. So that we get us all the vendors who were not in California. Okay. Example of where clauses use logical operators. Continued. Okay, so we can say, it can get pretty, here's an example of how you can combine comparisons with and, or, and not. And you get to the point where it's pretty confusing. Okay, so this first version is, you can kind of understand it, but it's pretty confusing. Here, we just simplified it. Okay, and we simplified it using a logical technique that's called De Morgan's rules. And it turns out that when you have a not A or B, you can change it to a and not A or B is oh well, yeah, this is more than De Morgan's laws. So I apologize for that. But this is a case where the second expression is a simplified version of the first, using some insights and some thoughtfulness. A compound condition without parentheses. Okay, so you can write these compound conditions that we've been talking about without parentheses, and there is an order of precedence. So generally speaking, when we have to use the order of precedence in these formulas, we first of all we figure out what's the strongest. Okay, and then between things that are equally strong, we do the one on the left before the one on the right. Okay, and this was true of the arithmetic stuff, even though I didn't say the left and right stuff. So here we do the nots before the ands, before the ors, and if we have equals, we do the one on the left before the one on the right. Okay, now I don't want you to rely on these. I want you to put the parens in. So here's the version of this with the parens, which is much more manageable. Okay, this is a good coding practice. The one before, kind of a mess. Not really the kind of thing that you would want a teammate to leave behind for you, or that you would want to leave behind for a teammate. Okay, now the in expression is really cool. Okay, because it turns out it's a really succinct way to express something. So you can say where, and then you have an expression in, and then you have a list. And you can either have a literal list, or we're going to learn about subqueries. Subqueries have a chapter all to their own, but we're going to show you one here. So we can say where terms ID in 1, 3, 4. So it can be 1 or 3 or 4. Okay. If the value is 6, then it's going to fail. If it's a 1, a 3, or a 4, it's going to pass. Or we can also have a not. So we can say where vendor state not in California, Nevada, or Oregon. Okay. So if it were New Jersey, it would pass. If it were Oregon, it would fail. And you can actually build the list with a query. So this is a query within a query. It's called a sub query. So we say where vendor ID in, select a vendor ID from invoices where invoice state equals that. So we don't want the vendors who have invoices from a certain date. Now, why that is, I don't know. So we can use between, where the test expression is between one expression and another, or not between. The key with the between, remember, it includes the endpoints. Okay. So a between phrase with literal values, where invoice date between this date and that date. It includes the endpoint dates. Between phrase preceded by not, where vendor zip code not between this and this. Okay, so the between expression includes the endpoints, so the not would cover them as well. A between phrase with a test expression coded as a calculated value, where this calculated value between 200 and 500, again, includes those endpoints. And a between phrase with upper and lower limits between credit total and credit total plus 500, again, includes the endpoints. Don't forget that. Here's a cool thing that works for character strings. We say where some expression, okay, is like a pattern or not like a pattern, and we have wildcard symbols. Okay, wildcard symbols like you use for file wildcards when if you're working at the command line in most operating systems, and you want a directory of files that are that include a certain pattern. They've got wildcard symbols as one of the features that came from there. Okay, so let's look. We can say where vendor city like san percent. So what does percent as a wildcard mean? Well, it means from here on in, we can match anything. So it would match San Diego and Santa Ana. Okay? Or we could say the other wildcard is an underscore, and it means I'll take anything in this position. So when we say vendor name like compu underscore percent, it would match CompuServe and Computer World. Regular expressions are the cool way these days to match character strings. Okay, and whereas SQL didn't originally have this capability, it's had it as part of the standard for quite a while now. So we have these meta characters, okay, that we use to build a pattern expression. Okay, so let's look at what those pattern expressions could look like. If we just have plain old characters, then we're trying to match that. So we're saying we are trying to match an SA anywhere in the string. Okay, so the operator we use is regexp, and that is actually the operator regexp. Okay, so we say vendor city regexp SA. Any value that has an SA anywhere is going to match. Okay, sorry. The second one, where we have a circumflex before the SA, it says, we want the SA combination, but the circumflex says starting at the beginning of the string. Okay, so it's only going to match Santa Ana and Sacramento. Here, and then the third one, we want to match NA, but this $sign says only at the end of the string. That's why we're going to match Gardena, Pasadena, and Santa Ana. Here's some more. We can say regex RS, and then this bar says or SN. So it's going to match RS or SN anywhere in the string. So it's going to match Traverse City and Fresno. Okay. We can say that we want to match N plus, and this becomes a character set, either C or V. So it's going to match NC and NV, but not NJ or NY. Okay, and we can also have a character set or a character class where we say we want to have a capital A through capital J. So again, it would match NA or NJ, but not NY. So we're going to get NC and NJ, but not NV or NY. A couple more. So we've got this DAMI, and either an E or an O and an N. So that would match Damien and Damian. Okay. And this example 8, we have one letter from A to Z, and then the second one is either an A, E, I, O, U and an N, and they have to be at the end. So we can get O-N, E-A-N, L-I-N. Okay. I'm sorry, T-O-N-E-A-N, L-I-N. All right. Now, regular expressions are an acquired skill. All right. The O'Reilly book, there are two O'Reilly books on regular expressions. One is a pocket reference. It's about 100 pages long. Another one is a comprehensive text. It's over 400 pages long. So, and there are quite a few, if we bring up the web here, there are, sorry, let's open up a new window and see if we can bring it down here. Okay. But we can, there's a regular expression website that I really like a lot. Oh yeah, it's called regular-expressions.info. If we go there, this is a guy who's the author of a lot of the regular expressions book. There's also a regular expressions cookbook, which he wrote. And you can come here and you can learn a whole lot about regular expressions. What kind of skills do I want you to have? Well, I want you to pick up the beginner skills, okay? And one of the things that I do in order to build my skills over time is, of course, you can either use a regular expression approach in one of these where clause, or you could use one of the other approaches that we already saw. One of the things I try to do is I try to use a regular expression so I get better at them. Okay. And again, I can think my way through them. I can look them up in books. The last thing I do is that usually any organization has a really capable person with regular expression, or maybe two or three. And that's the case where you want to bring a coffee and some donuts and say, look, I need some help with this. And the other thing you can do sometimes if you're looking for a regular expression for something like a zip code or telephone number or something like that. You can simply Google that, and you'll find some good regular expression patterns uh, on the net for that. And in fact, one good place to go is a place that we just were, where we which is regularexpressions.info. Okay. Nulls. Okay. When you're trying to detect a null in a column, nulls are very special values. Okay. What they mean is that we didn't put a value there. Okay. Uh, you just can't say where uh, column equal null. The only way to detect it is to use is null or is not null. Okay. Here's a select statement that retrieves rows with 0 values. So here we say where invoice total equals 0. Okay. Here's one that retrieves non-zero values. So invoice total, this is one of the ways that we can say not equal 0. That works pretty well. Here's a statement that retrieves rows with null values. So we can say where invoice total is null. Okay. We can say here where invoice total is not null. Now, here's the thing to remember. Null is no value. It's not the same as a 0. Okay? They're different. The expanded order by clause, okay? Instead of just naming one column or an expression for a column in the order by clause, you can have more than one, okay? So we say here, well, first of all, you assume that you always want to sort ascending, okay? If you want to sort largest to smallest, add desk for descending, okay? And that's true for any column that you use. But what if you wanted to consider more than one column? Well, okay, here we're considering one column, vendor name, okay? If we don't say desk, we're going to get them in ascending order. Okay, that makes sense. So you have to know what ascending order is going to be, though. You're going to get null values, then special characters, then numbers, then letters, and something that's really surprising to some people is you get the capital letters, you get the uppercase before you get the lowercase. Okay, so yeah, you think you know what order things are going to show up, but you're sometimes surprised. And then if you want it in descending order, okay, you still get the null values first. Why? Well, that's because the way the standard works. I guess people thought that would be helpful. Now, what if you want to consider more than one column? Okay. Nope, we didn't get to that. Here's one column in a descending sequence. So vendor name descending, the Z's come before, the ZY comes before the ZI comes before the ZE comes before the Y. Okay. What if you want to use more than one column? Okay. Now, for people who've been sorting things for their working life, okay, they typically know how this works. Okay. For people who are new to sorting, it's kind of a surprise. It turns out to be easier than you think. What does it mean to sort on 3 columns? Well, you look at the first, okay, and you compare them. If you have a clear winner, the sort activity is done. So if row 1 is greater than row 2, I mean, if we're in ascending order, if row 1 is less than row 2, then row 1 is going to get sorted before row 2, okay? If they're equal, then we have to go to a tiebreaker. Then we go to the second column, okay? And then we say, okay, are these different? So if the vendor city is less than the one in row 2, well then row 1's going to come out on top again. Otherwise, row 2 is going to come out on top again. Or maybe there's a tie here as well, in which case we're going to consider column 3. Okay, so columns 2 and 3 only come into play when you have a tie in the values in column 1. Okay, so if you don't have ties in column 1, you never get to consider what the values were in column 2 and 3. Okay, it's only for tie breaking. Here's an order by clause that uses a column alias. So this demonstrates again that you can use a column alias in order by. We create a column alias address. So we're able to use that. That's very nice. It only works because the order by is one of the last things that we do. Okay, and it turns out that that value is available at that part of the workflow life of an SQL queries. Can't use a column alias in a where clause. Wish you could, can't do it. You just have to copy the formula again. Okay. Here's an order by that uses an expression. Order by concat this. Okay, so you can always use an expression in an order by. It can be a repetition of an expression that you used in one of your column specifications or not. Okay. Here's an order by that uses column positions. You can so you have your select clause. So the first column is vendor name. The second is the concat expression. The third is vendor. I'm sorry. The first is vendor name. The second is the concat expression. Okay. You can, instead of giving it instead of coming down here and saying, I guess we could say order by address, comma, vendor name. Instead of that, you can say what the column number is up here. So address is column 2, vendor name is column 1. So you can do that. I generally don't. I don't like that. Is it acceptable? Yes, it is. I'm just not a fan. Limit. Okay. Now, uh, if you if you don't have a limit clause, then you're going to get all the rows that qualify, all the ones that pass the where clause, all the ones that are not eliminated by the use of the distinct keyword. Okay. But what if you only want a certain number of them? Okay. What would be the use case for that? Well, this is the classic. Okay. We say that we want to order by invoice total descending. So we have the biggest invoices first, and then we say limit 5. Well, what do we get? We get the top 5. Isn't that beautiful? Okay. Or we can say something like limit 2, 3. Okay, so what's the first thing? This is how many you're going to skip. Okay, so if you limit 2, that means, okay, we're going to skip the first 2, invoice IDs 1 and 2, and then we're going to do 3. So we get 3, 4, and 5. Okay. These kinds of expressions are good when we're trying to get pages of answers. And then the last one here, we're going to skip the first 100, limit 100 comma 1000. So we're going to skip the first 100. So the first value that we get is 101. And then we'll give up to 1000, okay? And we only get 14. Why is that? Well, because we only have 114 rows. Okay, so it's not going to manufacture the rest of the 1,000 because we would take up to 1,000. But it skips the 100, starts with 101. It would have given us up to 1,000 if we had, but we only get 14 because there are only 114 rows in the invoices table. That is it. Pretty long chapter, a lot of different features. Okay. We're going to have fun with these in the homework assignments, the exercises that we do. But this is all pretty straightforward stuff. These are most of the features of the select. What are we not doing? We're not using more than one table at the same time. We do that in Chapter 4. So I'm going to say bye for now, and I'll see you next time. Bye-bye.